Okay, we're going to look at properties of 2D shapes. This is a brand new topic. We've finished algebra because you did the test. And we're going to be looking at properties of 2D shapes, starting with triangles. So we're going to look at classifying triangles. Now, with triangles, we're going to classify them according to the length of their sides and also the size of their angles. All right? So let's have a look. First of all, we can classify triangles according to their sides. Here we go. And there's three types of names we can use if we're going to classify the triangles according to the lengths of their sides. So an equilateral triangle has three equal sides, all right? And the way we show that is that we say that this side and this side, all three sides are equal, so we use a single dash to show that they're equal, all right? So the length of this side, let me just get a little pointer. So the length of that side is equal to the length of that side, which is equal to the length of that side. Okay, that's an equilateral triangle. And we use three dashes, right? A single dash on each side to show they're all the same length. Now, what about an isosceles triangle? An isosceles triangle has two equal sides. And again, I'm going to use two single dashes to show that these sides are equal. Okay, so two sides equal. In this particular diagram, this side here is equal to this side here, but not equal to the bottom side. Obviously, the bottom side is shorter than the other two sides. So an isosceles triangle has two sides of equal length. What about a scalene triangle? Well, a scalene triangle has no sides which are equal in length. Now, how do we show that on the diagram? Well, I can't use a single dash for each side because that means they're all equal. So I've got to use a different number of dashes for each side. So one dash for one side, two dashes for another side, and then three dashes for the third side, right? Because each side has a different number of dashes, it means that they're different lengths, okay? So an equilateral triangle has three equal sides, three. An isosceles triangle has two equal sides, and a scalene triangle has no equal sides. So that's according to the side length of a triangle. What about classifying a triangle according to its angles? We can do that too. So a triangle which has got three equal angles is called an equilateral triangle, of course. Okay, and in fact, there's something special about an equilateral triangle. Not only are the angles equal, but they are all 60-degree angles. Okay, so an equilateral triangle has three equal angles, and we could make it a bit more detailed, three equal angles of 60 degrees. Okay. Now, an isosceles triangle has two equal angles, and I've marked them here. Two equal angles, and they're opposite the equal sides. So if I put the equal sides in here, you can see that the angles, the equal angles are opposite the equal sides. And a scalene triangle has no equal angles. Now we've used a different symbol for each one. So we've used like a dot for that angle, a single arc for this angle, and a double arc for this angle. So I've used three different symbols to show the three different sized angles. Okay, so if I'm classifying a triangle according to its angles, if it's got three angles of 60 degrees, it is equilateral. If it's got two equal angles, right, any two angles which are equal, then we call it isosceles. And if none of the angles are equal, we call it a scalene triangle. Okay, now what about some other special cases? Well, if I've got a triangle which has one 90-degree angle, right? Now this is the symbol for a right angle, as we know. So that angle there is 90 degrees, just where I drew the little box. So a triangle with one 90-degree angle is called a right angle triangle. What if you've got a triangle with an obtuse angle triangle? Okay, an obtuse angle triangle is a triangle with an angle which is between 90 and 180 degrees, okay? So that angle there that I marked has to be bigger than 90 but less than 180 degrees. Right, that's called an obtuse angle triangle. and it's got one, it can only have one obtuse angle. What about an acute angle triangle? Well, if all three angles are acute, now remember acute angles are 0 to 90, but not including 0, not including 90. Okay, so acute angles are between 0 and 90. Okay, so if all three angles are between 0 and 90, then we call it an acute angle triangle. Right, so those are all the labels. Let's have a look at some examples now. Okay, so I want you to name the first triangle according to its sides and angles. Okay, now obviously for this one it's got 3 equal sides, so that's just an equilateral triangle. I guess technically you could call it an equilateral acute, but equilateral will do. So equilateral triangle. Right, make sure you get the spelling right. Equilateral triangle. Now this triangle here, it's got 2 equal sides. So we call that an isosceles triangle. This is isosceles is what most students spell incorrectly, so that requires a bit of practice. Isosceles triangle. And now this has got no equal sides, so I'm going to call that a scalene triangle. Now it did say to also name it according to its angles, didn't it? So if I look at the angles in each triangle, so if you look at this angle here, and here, they're all 60-degree angles, aren't they, for an equilateral triangle? And 60 degrees is an acute angled triangle. So we could call that an equilateral acute angle. But actually, equilateral triangles always have acute angles. So I'm just going to leave that as equilateral. But this one here, if you look at the angles here, now these are the 2 equal angles here, and the third one is not equal. But what you'll notice is that all 3 angles are acute. So I could call this an isosceles acute triangle, right? So there's the isosceles refers to the 2 equal sides, and the acute refers to the fact that all those angles are acute. Okay, now what about this one here, scalene? Now if you look at these angles here again, so there's one angle, here's another one. It looks like that all 3 angles are acute as well. So I could call this a scalene acute triangle. Okay, so those are the names. Let's have a look at this one. Now this has got 3 equal angles of 60. So we're going to call this a equilateral triangle. Equilateral triangle. Now here we've got the same picture as before basically, but we've got 2 equal angles here. So this is also going to be called isosceles. And then an acute angle triangle. And this one here, we've got, well, all angles are different, aren't they? You can see single arc, double arc, triple arc, so all angles are different. So that's a scalene triangle. But also all 3 angles are acute, so it's a scalene acute triangle. Okay, now what about this one? Here we have a right angle triangle. And we're not going to call it a right angled acute triangle because, hang on, my pen's gone a bit funny. There we go. because all right angle triangles have two acute angles. We're just going to call that right angle. This one here looks like all three angles are different, doesn't it? So this angle here, this one here, this one here, they're all different. So that means it must be scalene. And all three angles look like they're acute. So it's a scalene acute triangle. And last of all, now here you can see that we've got a big angle here. That's an obtuse angle. So it's got to be an obtuse angle triangle. It also looks like none of these sides are equal. It looks like all the sides are different lengths. So this is going to be a scalene triangle because all the sides are different lengths. But also we have an obtuse angle there. So it's a scalene obtuse triangle. Okay. And that is it.